Hello everyone. Our lecture today is about shearing stress and bending moments. This lecture is introduced in the period of coronavirus spread. God save you and save our dear country. Firstly, we should talk about bending moments at point O. What's the meaning of bending moments? Is represented by couple at point O and given by M. So M equal force times normal distance. Then force times normal distance equal bending moment or represent couple. We have two cases of this force. If this force rotates in anti-clockwise direction or clockwise direction. If the force rotates in anti-clockwise direction, so it's positive F. If it's in clockwise direction, we use negative F. We find the couple at point O, so it's called M naught. And the normal distance between force and the point is A. So the distance or normal distance is A. In first case, M naught equal A times positive F. And in the second case, M naught equal A times negative F due to direction of rotation. Now we talk about shearing stress, which is given by S. Shearing stress, which is external force acting on beam in normal direction and given by S. Now let we have a couple M and resultant of force R. We can analyze the resultant of force into two components: shearing stress and tension. We searching about in this chapter about couple and which is called bending moment and shearing stress S. Now transfer forces acting on beam. Let we have a beam BOQ. We have three parallel faces BOQ. Let O on the surface which divided the beam into two parts B and Q, which called A, B, C, D. The first part affected by F1, F2 and F3, and second part Q affected by F4 and Fn-1 and Fn. So we note that the beam affected by forces F1, F2, F3 to Fn. And due to these forces and this effect of forces, the beam may divide into two parts B and Q. Now we will study two parts, part 1 and part 2. Part 1 is B and part 2 is Q. Forces is F1, F2 and F3. Now the resultant of this force is given by R1 and its couple is given by M1. As you see, M1 is couple and R1 is the resultant of its forces. And the other part 2, which given by Q, forces is F4 to Fn. We have resultant force R2 and couple M2. Let we analyze the forces R1 and R2 into two components, T, which represent tension, and S, which represent bending or shearing stress. Now, for R1, we have two components, S1 and T1, and for R2, we have two normal components, T2 and S2. In case we studying beam in equilibrium case, so S1 will equal to S2 and T1 equal T2 and M1 equal M2, shearing stress and tension and bending moments. Now, we talk about types of supporting or fixing. Supporting or fixing. One, the first, simple supporting. Simple supporting. Let the beam is surface of supporting, and point A is point of supporting, and also point B is point of supporting. Due to every point of supporting, we have normal reaction on the surface of supporting. Due to supporting point A, we have RA, normal reaction due to point A, and RB, normal reaction due to point B. The second is articulatory fixing. In this case, there exists reaction force. We have two components of reaction. This point is called articulator. We have two components of reaction, X and Y. Then the resultant reaction are equal square root for X squared plus Y squared. 3. Exactly fixing. Exactly fixing. Exactly fixing the reaction equivalent to force R and couple G. Not exact. We deal with simple supporting. We deal with simple supporting in all our examples. Surface of supporting, point of supporting, normal reactions. Steps to solve examples on shearing stress and bending moments. First, draw beam and all givens in the example. And determine points of supporting. Firstly, we should determine point of supporting. Why? To find and draw reaction due to point of supporting. 2. Determine length of each part after putting weights and supporting points. We should find due to point of supporting and weights lengths of each part or region. Look in this figure. The beam is AD, and A and G is point of supporting. Due to point of supporting, we have two normal reaction, RA and RD. Let we have two weights at point B and point C, 3 and 6. So we have 3 regions. First region, second region, third region. The first length is x1, the second length is x2, the third length is x3, which is given in all examples we will deal with. 3. Studying equilibrium for rod and taking moment to find reaction. If we're studying here equilibrium for total rod, RD plus RA equal 9. RA and plus RG equal 9. That's due to equilibrium for all beam. Now we should find RA and RD. So we will take moment or about A or about D. We notice that if we take moment about A, we can cancel RA to find RD. And the converse is true. For we dividing rod into some regions due to weights and reactions. As you see, first region and second region and third region. And we will study every part due to forces and reaction with its distance. First region, not exact. The first region is from A, it's tended to B, not at B. The second region from fixed point A and before weight 6. And the third region from fixed point A before and point before D. Now, to solve every part, we should assume that a point B, which is distance from fixed point A, is x. And shearing stress at this point in downwards and given by S. The first region from A to B, distance is x and shearing stress is S1. And reaction is in R1, RA. Now, we have two steps. First, studying equilibrium to find S1 as S1 equal RA. Second, to find M1, we take moment about point B. We can cancel S1 and use only RA and not exact clockwise or anti-clockwise to determine the sign of force. We find M1. Also, the second region, we will study equilibrium for this part. Let point B and distance is x. Now, 3 plus S2 equal RA. It's for equilibrium due to this part. And we will take moment about point B. Now we can cancel S2 and use weight 3 and reaction RA to find M2. Also, for third region, the same two steps, 3 plus 6 plus S2 equal RA to find S3, and we will take moment about B. We can cancel S3 and use 6 and 3 and RA to find M3. Step 5, we will studying shearing stress at different points on the beam. Now we have S1 and S2 and S3. We write it in this form: S1, S2, S3, which we can have from the first region and the second region and the third region. Finally, we draw the graph between X and S. Six, the relation between bending moment M and different point X. We also have M1 and M2 and M3. We write M1 and M2 and M3 we have before. And draw the graph relation between X and X, different points on the beam, and bending moment. We have M1 and M2 and M3. Example 1. We should read the example carefully. First, we have beam AD. The two extreme points is A and D, of length 3ft along, and negligible weight. That's mean the weight of the beam not occur in studying equilibrium for all beam. Is supported at its ends. So point A and point D is point of supporting. So we have RA and RD normal reactions. And carries two weights, 3 and 6. We have two weights, 3 and 6, at point B and C. Now we haven't know where point B and C, but we are sure that's between A and D. Given that AB equal BC equal CD, that means that every part is equal 1 and 1 and 1 due to length of beam is 3. Determine shearing stress and bending moment at any point on the beam. Then draw the graphs of bending moment and shearing stress. Now, looking that we have a beam AD supporting from its ends A and D, then A and D is point of supporting, so we have normal reaction RA and RD. And also we have two weights 3 and 6 at point B and point C, and three parts are equal, so this length AB equal 1, BC equal 1, CD equal 1. We finished the graph. To solve this problem, first we're studying the equilibrium for all beam. Then RA plus RD equal 9. RA plus RD equal 9. That's first. Now, to find RA and RD, we should take the moment. Or about A or about D. Take a moment. We will take a moment about A. Take a moment about A. Then we can cancel RA. Now, RD equal RD. It's anti-clockwise, so positive RD times 3 and 3 times 1, but it's clockwise, so negative 3 times 1, and 6 is clockwise, so it's negative 6 times 2. Now, to find RD, RD, we have 3 RD minus 15 equals 0, divided by 3. We not exact. RD equal 5. We take this relation, RD equal 5, in relation 1, RD equal 5, and RA plus RD equal 9. So we can find RA, which is equal 4. Now we will divide the beam into 3 regions. Let we have point B, which distance is x from fixed point A. We will assume that point A is fixed at all parts we study. The first region is from A to before weight 3. And the second region is from A and before weight 6. And the third region from point A to before point D. That's first, that's second, that's third. let point O is 0, that's distance from fixed point at fixed point is 0. Now we will studying this part first. Let B1 is distance from A is x and RA equal 4, and the stress, shearing stress, is S1. We will have two steps. First, studying the equilibrium at this part. S1 equal 4. S1 equal 4. Then to find M1, we should take a moment about point B. About point B. Then we can cancel S1, and 4 is clockwise. Then it's equal negative 4 times distance is x. Then M1 equal negative 4x. Negative 4x. Then we have S1 and M1. Studying second region, part 2. It's before weight 6. Let we have point P, which distance is x, weight is 3, this distance is 1. To find the distance between 3 and S2, total length is x, and this part is 1, so the distance from 3 to S2 is x minus 1. We will studying two steps. First, studying the equilibrium for this part. So, S2 plus 3 equal 4. S2 plus 3 equal 4. So, S2 equal 1. To find the moment, we will take a moment about point B. We have two forces. 3 is anti-clockwise, so 3 times x minus 1, and 4 is clockwise, negative, this part is positive. negative 4 times x, negative 4x. Negative 4x times 3 times x minus 1. So negative 4 equal negative 4x, 3x minus 3. Then M2 is equal negative x, negative 3. To studying the third region, we have RA and 3 and 6. That's point B is before supporting point D. Now, from B to the fixed point A distance is x. This part is 1 and this part length is 1. So the distance between 6 and S3 it's equal x minus 2. Studying the equilibrium to this part. Now S3 plus 6 plus 3 equal 4. We can find indirect way S3 equal negative 5. Now to find M3, we will take a moment about point P. We can cancel S3. We have 3 forces. 6 is anti-clockwise, then 6 times x minus 2, and 3 is anti-clockwise, equal 3 times x minus 1, and 4 is clockwise, it's negative 4 times x, as you see. We will write it in simplest form. It will be M3 equal 5x minus 15. Now we will write the relation between shearing stress and difference point on the beam x. S1, S2, S3. 4, 1, negative 5. That means that the S is a fixed point. We can draw it as line parallel to x-axis. In these intervals. From 0 to 1 equal 4. from 0 to 1 equal 4. That line represent S1 equal 4 from 0 to 1. And also from 1 to 2 equal 1 line parallel to x-axis equal S equal 1 from 1 to point C at point 2. From 2 to the point D at 3 equal negative 5. Let this point is negative 5, so it parallel x-axis at negative 5, S equal negative 5. We can match all parts by these points. Now we finish the relation between shearing stress and different point on the beam. Let we write the relation between bending moment M and different point X. Relation between M1, M2, M3 we have before. M1 negative 4x, M2 negative x minus 3, M3 5x minus 15. What's these points? These points, due to substitution in the relation. So if x equals 0, then M1 equals 0. If x equal 1, then M1 equal negative 4. At x equal 1, M2 equal negative 4. At s equal 2, M2 equal negative 5. At x equal 2, M3 equal negative 5. At x equal 3, M3 equal 0. We can test our result as we should beginning with 0 and finished by 0, and every ending number, it's the beginning also number, negative 4, negative 4, negative 5, negative 5. Let we graph negative 4x represent linear function from 0 and 0, 1 and negative 4, 0 and 0, 1 and negative 4, and match the 2 points. And also 1, negative 4, 2, negative 5, this point, and match 2 points. And also 2, negative 5, and 3 and 0, and match this point. This graph represents the relation between bending moment and different points on the beam. Example 2. A beam of weight of length 16 of negligible weight. That means that the weight of the beam doesn't occur in studying equilibrium, is supported at 2 points. 2 ft from one end and 3 ft from the other end. We have two supporting points, but not in the two extreme points, but first from distance from its end 2 ft, and the other it's from the other end 3 ft. Carrying load 5 on its middle point. Carrying a load 5 on its middle point and 3 on each end, and weight 3 on each end. So we have 3 weights, 5 in the middle point, and 2 weights equals 3 in each of the extreme of the beam. Determine shearing stress and bending moment. Now we have beam let's is A E. We have two supporting points. Distance 2 from its end, and the other is distance 3 from the other end. Let's the first supporting is B. So we have normal reaction RB, and the other supporting point is D. So the normal reaction RG. We have three weights. First, from the middle point, which equal 5 at C, and two weights which are equal and equals 3 from all of its ends, 3 and 3. To find the distance, we have 2 and 3. Where 5 from its middle point and its length is 16, so left part and right part are equal 9. 3, so this part equal 5. 2, so this part equal 6. Now, to solve this problem, first we will study equilibrium for the rod to find reactions and taking a moment about B or D. We notice that RB plus RD equal 3 plus 5 plus 3, 11. RB plus RD equal 11. So now we will take a moment about point B. We can cancel RB. We have force 3, 5, 3, RG. 3 is anti-clockwise times distance 2, and 5 is clockwise. 5 is clockwise with distance 6. That's equal negative 5 times 6. And RD is anti-clockwise. It's positive. RD times 11 is positive. And 3 is clockwise. That's negative. 3 times 3 plus 5 plus 6 equal 14. To find RD, we notice that it's positive. RD positive. So 11 RD minus 66 equal 0, divided by 6, then RG equal 6. From 2 in 1, we can find RB. That's RB plus RD equal 11. So RB equal 5. Now we assume that we have point B, which distance from fixed point A. We assume that the point A is fixed. So for every part we have point B distance from fixed point A is X, and they have shearing stress S, S1, S2, S3 due to number of regions. What's the number of regions in this example? From A to B, from A to C, from A to D, from A to E. We have 4 regions in this example. For first region, this weight is 3, this is S1, then S1 plus 3 equal 0. So S1 equal negative 3. S1 equal negative 3. It's shearing stress. To find bending moment M1, we will take a moment about point B. We have 3, which is anti-clockwise, so it have a positive sign. 3 times distance x, so M1 equal 3x. Studying the second region. Second region is from A to before the weight 5 at point C, which is in the middle. So this distance is 2. All this distance is x. This distance from B to B is x minus 2. First, we're studying the equilibrium. S2 plus 3 equal 5, so S2 equal 2. To find bending moment, M2, we will take a moment about point B. About point B, we have two forces, RB equal 5 and 3. 3 is anti-clockwise, so it equal 3 times x, 3x. And 5 is clockwise, so it negative 5 times x minus 2. We can write it in simplest form. We have M2 equal negative 2x plus 10 bending moment. The third region is from A to before supporting point G. Let we have point B. This all distance from A is x, and having S3, we have weight 5 and weight 3 and reaction 5. Studying the equilibrium for this part, then S3 plus 5 plus 3, S3 plus 5 plus 3 equal 5. Then we have S3 equal negative 3, shearing stress. To find bending moment M3, we will take a moment about point B. We have 3 forces, M and 3 and 5. Now, M5 is anti-clockwise. 5 is anti-clockwise, so it's positive 5 times x minus 8, and 3 is anti-clockwise, then it's equal 3 times x, and RB is clockwise, it's negative sign, equal M equal 5 times x minus 2. Now we put it in the simplest form. M3 will equal 3x negative 30, which is bending moment. The fourth region, that's from fixed point A and before point E, which have the weight 3. The distance from B to fixed point A is x, and shearing stress is S4. We have weight 5 and weight 3 and two reactions, RB equal 5 and RG equal 6. Distance A to B equal 2, B to C equal 6, C to G equal 5, and this part is x minus 13. 13 is 5 plus 6 plus 2. Now we will study equilibrium for this part. Then S4 plus 5 plus 3 equal 6 plus 5. Also we can find S4, which equal 3, shearing stress. To find bending moment M4 at point B, we can cancel S4 and deal with 5 and 3 and RB and RG. 5 is anti-clockwise, then it equal 5 times x minus 8, and 3 is anti-clockwise, that means that equals 3 times x, and RD is clockwise, that's negative 6 times x minus 13, and RB equal 5 is clockwise, that's negative. Negative 5 times x minus 2, and we will write it in simplest form to find m4. That means that m4 equal negative 3x plus 48, that's bending moment. Now we should write the relation between shearing stress S and different point X on the beam. That means that S1, S2, S3, S4, which is fixed. That means that it will be represented by line parallel to X axis in the opposite interval. From 0 to 2 is negative 3, and 2 to 8 is 2, and from 8 to 13 is negative 3, and from 13 to 16 is 3. Now from 0 to 2 is negative 3, and from 2 to 8 is 2, and from 8 to 13 is negative 3, and from 13 to 16 is 3, and match these parts by this point. That's the graph for the relation between shearing stress S and different point on the beam X. Now we should find the relation between bending moment M and different points X on the beam. That's M1 and M2 and M3 and M4 and the opposite interval. Zero, to find M1 at 0 equals 0, at 2 equals 6, and M2 at 2 equals 6, and at x equal 8 equal negative 6, and at x equal 8 M3 equal negative 6, and at x equal 13 M3 equal 9, and at x equal 13 M4 equal 9, and at x equal 16 M4 equal 0. That means that our substitution is true and M is true. To draw the graph, M1 and M2 and M3 and M4 is a linear function. First, 0 and 0, 2 and 6. 0 and 0, 2 and 6, and match 2 points. And also from 2 to 6 and 8 to negative 6, and match these 2 points. And from 8 to negative 6 to 13 to 9, and match 2 points. And from 13 to 9 to 16 to 0, then match these points. This graph represents the relation between bending moments and different points on the beam. That's the whole solution of this example. Now we have 2 examples about shearing stress and bending moments. If you have any questions, I will with these questions on Google Classroom. Thank you.